One, and we should be kind of live. Hello, everybody. Let me start my camera and stop my screen share. How about that? Hi, everybody. Welcome to this third session of QGIS Open Day on September the 24th, 2021. We're rocking an African crew today with myself, who's ex-African, I guess, and Charles. Hello, Charles.
Unmute myself first. Hello, everyone.
And Vicky. So hello, Vicky.
Hello.
And we're going to be showing you some fun and games with MQTT, OwnTracks, Node-RED, Postgres, and QGIS, of course, QGIS. So buckle up, take a seat, pull out your beer or coffee as you prefer, and we're going to take you on a little bit of a tour of how you can link all these different technologies together. I'll explain a little bit what they are as we go. I'm just going to take my web browser and put it over here because it's also my control panel for the YouTube channel. And I just want to be able to see if anybody's saying anything. Hi, Luigi and Maria. Welcome to the session. So I'm going to first just start with a few simple explanations of what all these different terms that I mentioned are. So I'll share my screen up here. So this is just a basic diagram showing you kind of the architecture that I'm going to be demoing. And I guess we can start on your mobile. You have an iOS or an Android device, and you install this OwnTracks application. It's an open source and free application that you can install on your phone. And it's kind of designed to replace Google or Apple or whoever else usually does your tracking where you go kind of activity. And it's a private and potentially secure way of like managing your location history from your phone. So if you've ever used Google's Where Have I Been? I forget what the website's called. Basically, they've got a site where you can go to and you can see all the tracks of wherever you've walked and taken pictures and what have you. But that's obviously shared to Google. But in this environment, OwnTracks allows you to push the data to your own server. And the way that it does it is using this protocol called MQTT, which I can't remember what it stands for, but it's basically a lightweight messaging bus that you can use to pass messages between devices. And the messages can be have a guaranteed or a non-guaranteed delivery, and they can be guaranteed to deliver once or multiple times. So they've got these three quality of service levels that you can send a message with. And OwnTracks is quite cool. If the server's offline, it will kind of store up the messages on this side, and then when it has access to the server, it will go and push them off to the server. So MQTT is the transport protocol, and then you run a server, and on the server you install an MQTT broker, which is just basically a server. And that broker is responsible for listening for messages that were passed to it and then disseminating them to any other listeners in the network. And every message has like a URL. It's called I forget what it's called, but it's got a kind of something that looks like it's called a topic, I think. Something looks like a URL. And you can kind of, in the broker and in your clients, you can parse for the URL to decide which messages you want to listen to. If you've got many devices, they can all be connected in the same system. So we could have like a Cartosa MQTT broker, and everybody could be pushing their positions to that same device. And then you could listen for, I just want to see Charlie's messages, or I just want to see Tim's messages or Vicky's messages. So Mosquito is one implementation of an MQTT broker. It's by, I think it's the Eclipse Foundation sort of maintains it. And you can get a Docker image of it. It's really easy to deploy an instance of it. But there are other ones as well. So I'm running this Mosquito broker on my server. And then on top of that, we've got something called Node-RED, which we're going to demo to you, which is an Internet of Things extract, transform, and load, and workflow kind of design tool. It lets you do something like the QGIS modeler environment, where you build these sort of graphical directed acyclical graphs, and you kind of flow the data across the graph, and you can transform it in different steps and process it and so on. And then from the Node-RED, we're going to take the MQTT message and push it into Postgres, so that we can then connect to it from QGIS or from our web browser. I should just mention this green box here, that the whole thing I've got running inside of VPN. So I'm just using WireGuard, which is an open source, very easy to set up VPN. MQTT has a whole lot of security protocols, so you can use TLS, and you can have access control and all these kind of things. But in the simplest setup, I've just basically running it in my private network with very little of those things in place at the moment. All right. Any questions from our panel or the audience? Luigi saying
I've just loaded up I've just loaded up the YouTube, and it looks like your screen is blank. Yeah, I can see it in Jitsi, but I can't see it in YouTube.
I can see that. Okay, let's go and see if I can stop and start my screen share again. Thank you, Luigi. Let's have a look now and see if it's any better. Still disturbingly not showing anything.
Nope.
I'm going to just, what am I going to do? Oh, what am I going to do? I'm going to just try turn it on and off again. If that doesn't work, I'll try rejoin the session.
I suppose in the meantime, I can just chat about the concepts that you were explaining, for like maybe in more layman's terms. So basically, the stack involves using a mobile device which has got OwnTracks on it to capture location information, and then it's got a series of it's a message brokering system. So I think MQTT is MQ Telemetry Transport is the acronym. But basically, you don't really have to worry too much about like message brokers and that sort of thing if you're unfamiliar with it. The gist of it is that you're getting events and event information, and you're sending that information via like a custom protocol. So if you're familiar with like web development, like asynchronous job tasks, that's where message brokers are used. And MQTT is quite widely used, I think, with like Internet of Things devices and so on. So it's like a lightweight transport protocol. And then on top of that, we've got a like data interoperability and kind of like ETL transformation layer using Node-RED, which just transforms your information and then stores it in the underlying data store. I think that's the gist of it, right?
Mm-hmm. I'm going to have to try to rejoin the call, and that may stop the stream and it may boot you all out, but I think it won't boot you out. But that's the only thing I can think of. This is like the conference equivalent of can't get my VGA adapter to work on the screen. So those who are watching in the live stream, if you just bear with me for a minute.
Yes, someone's asked for the links to the tools, so I'm just going to dig those up quickly and paste them into the chat there for everyone. And we'll add them to the description later.
When I jump out, but if it does, we'll restart again shortly. So just stand by and we'll be back again. I'm just going to stop and restart the browser and see if it helps. I'm back. Could you see my screen locally in the call, Charlie, or not?
You mean in the Jitsi room?
Yes. Can you
Yeah,
see
I've
my
been able to see it the entire time. It's just on YouTube that we can't see it.
Yes, Luigi. Yeah. Can you see something? I can't see anything.
Oh, it's up now. It's up. It looks like it's
Is
up.
it working?
Turn it on and off again.
Ah.
Yay!
Okay, just goes to prove the IT crowd is 100% correct with their debugging approach. Okay, thanks everybody. Yes, for the links, we'll dig up the links and maybe we can add them to the show notes. Hopefully, if you have any more glitches, just pop me a note on the channel and we'll try it on the chat and we'll try it.
While you're busy, maybe I'll just go stick them in the wiki as well.
Okay, perfect. Yeah. Okay, so
yeah.
This was the picture I was trying to show you, which is basically, here's my mobile phone. I talk to the Mosquitoes broker over this MQTT protocol that then passes, it basically lets any client connect to it. In this case, Node-RED is connecting to the broker and saying, like, what messages have you received? And then Node-RED can filter those messages and do some data transform to the messages, including passing them over to Postgres in this case. And then from Postgres, we can pick up the data in QGIS. And then we can also look at the data in a dashboard that we make using Node-RED in a web browser. Okay, so something else I just need to do is just close this. These things that are going to go blink. There we go. Okay, so I'm going to switch over to my web browser now and show you how I constructed it. So it's going to be a little bit overwhelming at first because I've got quite a complex workflow. So what I will do is I'll just step over to quickly show you the basic concepts of how Node-RED works in a separate tab, and then I'll come back and I'll sort of break this down a little bit for you, what it does. But I thought it might be nice just to show you the end product first, which is this, which is like a dashboard that I've made, which is taking my track data and putting it in a table, the latitudes and longitudes, and this course is the heading and a timestamp, and you can give each device in OwnTracks its own device ID. And you can also pick up things like the battery levels and other device information. You can actually get the altitude of the device, the velocity, battery levels, course over ground, which is this course. You can also get whether the battery is charging or not, and one or two other little snippets of information. So what you're seeing here is like the history of my phone from this morning. I just sort of like reset the system, and actually this is just for the last little while, but because everything's in the database, I can actually pull in the history from the database as well, and you'll see the tables just growing in size here, and you can see the battery levels, for example, going up and down through the day, and the different directions and so on that I've been moving in. And you can see the changes in altitude as I've been moving around. The velocity chart is kind of a bit skewed because the last activity I did was walking, which is kind of slow. But you can see, like if I go driving, you would see some big bumps in there. And then this chart over time of the battery. I actually don't know what the blue line is for. I think it just picks up two separate devices. I haven't really gone to see why it's doing that. And then you can also have these sort of like latest data point kind of dials and things like that. I'm sitting in my chair at the moment, so my velocity is 0. Or more correctly, my phone is lying on the desk at the moment, so its velocity is 0. You can see, things like altitude and battery and so on. So this is basically all made from this flow over here. but it is a little bit complicated. So I'm going to just break down a little bit of the idea of how Node-RED works. And then I'll sort of just do a little walkthrough of this flow that I've made here. I won't try to construct it from scratch during this session. So if you want to get into Node-RED, the easiest way is to run it in Docker. But they have got instructions on their website, which are nicely laid out. And the basic principle of Node-RED is you create these things called flows, and each flow is just a flow chart. And into the flow chart, you can drop different nodes like this. A very similar concept to QGIS modeler. But again, the focus is much more on data transformations and doesn't have all the GIS processing things of QGIS modeler. In theory, you could actually call a QGIS model from this, because one of the things that provides is a shell executor here. So you can actually tell it to just run any command in a shell environment. So in theory, you could put Node-RED and QGIS desktop in the same Docker container, for example, and use the command line like executor for running a QGIS model. I haven't tried that yet, but it should be possible to do it. So let's look at the most simple kind of workflow. The workflow normally starts with an event happening. The simplest one is we can just like trigger a timestamped event. When you open this, you'll see some properties, one of which is saying, I want to inject this event after 0.1 seconds. So all it will do is like wait for me to deploy the workflow, wait for 0.1 seconds, and then send a message out here saying, here's a message. And then you can connect other nodes to that. Anyone where you see like two sides means you can connect something on that side and it will emit something on the other side. So for example, I could go and make an HTTP request like this. I think I found a rendering glitch in Node-RED there. I'll just move that away. It's there to stay, it looks like. Let me see if I resize my browser. No, it's not going anywhere. Okay. So now I'm saying basically trigger an event, and then after that event is triggered, make an HTTP request, and I can put any URL in here. Of course, we'll use qgis.org as an example, and you can say what it will be getting back from that URL. So we're just going to take a string back, for example, and then I can pass that result to like a debug message. It'll be like maybe the hello world of Node-RED for making a flow. And this debug message is basically takes this thing called a payload. So all along this flow, a payload is being passed. So this one here creates a payload, which is a timestamp. And then this one here takes in the payload. It just, at the moment, ignores it, but you could also append it to a query string or send as a request body, whatever you want to do with it. And the result of this will create a new payload, which then will be passed over to here. So let's deploy that quickly. There's a built-in debugger environment over here, which if you pass something to this message, it will write a debug message. I've already deployed, and that message was already sent, but I can trigger it again just clicking on this little button here. And you can see what I get back here is the HTML of the QGIS web homepage. Once you've got this, then you can do further things with it. So if we were wanting to parse something out of the HTML, for example, we could take the pass it to a parser here. We could say like send that to an HTML parser, and then this HTML parser, I could give it a selector. So if I go to QGIS homepage, and I want to, let's say I want to get, wait. Hopefully I'm still streaming. Are you guys keeping an eye on the YouTube chat room to see if I've fallen off the internet.
I think it was working a second ago. I just pasted all the links to the chat, and
Okay.
I'm sticking the links in the wiki page as well, the explanations of what the stack components do. So hopefully that's useful.
So let's say
it looks like you're still on YouTube at least.
Okay, great. So let's say, for example, I wanted to pull some element out of here. I could go here and inspect the time to new release, time to feature freeze, time until packaging. Let's do this one here. So I could click on here and use your browser's tools to copy the CSS selector, and then going back to my flow here, I could say I paste that selector in there, and now it should filter the message just to that piece of information, and I'll take the result of that to my debug message like that. And then I just trigger it again. And now you see I've pulled out just that single node from the website. So that's one use case, is just to like go out onto the internet, grab some information from somewhere, and then transform it and do something with it. I could put the time to release. I could do some further, text manipulation to actually extract this date here and then put a countdown calendar or something like that on my dashboard if I wanted to. That's like kind of how the Hello World would work. Just to show the Hello World, but in the context of MQTT, I can just get rid of these things here, and I can rather say, well, I want to start off by, I'm just going to reload my page because this black arrow is just conflicting with my sense of aesthetics. Wait, just stay here and save that. All right, black arrow is gone, yay. So let's say I wanted to take something from that MQTT feed that I've got. You can filter these as well if you've got a lot. So you can see there's MQTT in. You can also send messages out on the MQTT to the broker. And it's got a red triangle there. That means something is not configured yet. And I see that it's got a red box around the topic there. So I think the topic is location. I'm just going to check in my other flow actually, because I'm old and I can't remember the name of the topic. Okay, it's just hash. Okay, and then I can basically just take that and pass it straight to that and then see what happens. Okay. Now if I pick up my phone, I don't know if my camera is still on. I've got my phone in my hand here, and I open the OwnTracks application on my phone, and I press, there's like a manual send that you can press. And if I go look in here, well, a whole lot of things happen because I've got other flows connected to it. But you can see basically this payload of information arrived from my phone. And this is the one that I was referring to just now. This is just a text string, but it's actually in JSON format. So because it's a JSON document, I can actually use the parser. JSON
I don't know if you can zoom into that box a little bit.
Yeah.
YouTube is probably not going to be quite visible.
Yeah, let me see if I can do it like that. Okay, so this is basically what it's sent in here. And you can see it's got things like the location, acceleration, maybe. I can't remember what that one stands for. Altitude, my battery level. BS is not swearing at me. I can't remember what it stands for. That might be the charging one. Course over ground. Condition, I think I forget what that one is for. There's a page in the OwnTracks documentation which describes all these things. I'll pull that up just now. And then my latitude and longitude, and this TID is a little marker for each device. You can give it a 2-letter acronym. And then the TST is the timestamp. Is a Unix epoch time, so you can convert that over to a date and time if you want to. And velocity, and I can't remember what VAC stands for. But this thing is kind of like not very usable because it's just a text string. So what I can do is I can go and use a JSON parser like this, and rather than just send it straight out there, I can take this and parse it to a JSON object, right, and then deploy again like that. Just clear that, and I'll send another message from my phone. You see now I've got something that looks like a nice structured data set. It's easier to read. Okay, I was going to try to pull up the docs for the other things, but I'll pull up the link just now. So now I've got this thing here, and then I can actually start like breaking out pieces of information from there. So if I wanted to, for example, I could just write a function here. And in the function, let's say I wanted to just get the my current battery level. Then I could go like this, and just parse out the battery level by just saying, remember that payload thing I was talking about? I can say now the message dot payload equals message dot payload dot BATT. So just the name of that object over there, or that attribute over there. And a semicolon to finish, and then I'm done. And now if I send a message from my phone, you'll see I just get the one little data nugget from there, rather than all of the different attributes that get sent. That's the basic principle. Is that basically you have your phone. On your phone, you configure the server where your MQTT broker is. You tell it there's different modes it can operate in. So you can say like be quiet, so don't send any messages, or only send them manually. So like by me touching on the screen like that. Send them when there's a significant movement, which I think it's device independent. On an iPhone, it's something like 500 meters from your previous location. And on an Android phone, I think it's 200. I could be wrong. And then the other mode is just whenever I'm moving, just send messages. If you have an iPhone, you can also put it in command mode. I think in Android it works as well. In command mode, it means that you can also allow the broker to send messages back to your phone, and like, for example, pop up a message on the app, something like that. You can send various commands to it. So you set up the broker on your phone, the URI for the broker on your phone, and then it's just sending these messages on a bus, and you can parse them out using this kind of a flow. So if I jump back to the one that I started showing originally, you'll see that I've got also like the broker is an entry point here, but I've also got something else going on here. I've got this Postgres example here. So I want to just do another little hello world, which shows you how Postgres works. So there is a Postgres connector. I found the Postgres connectors. There's a few different ones. There are ones that work with like that let you send a string of queries from one node, and there are other ones that only work with a single query. And there's also a connector for PG Notify, which I've been trying to get work, which I can't make work yet. But that will let you like trigger events from things that happen in the database. For example, when an insert happens, and if you're an advanced user of QGIS, you know that QGIS also has PG Notify support on layer, on the layer properties. So we could, I haven't got it working yet, but we could potentially have things like an MQTT message comes in, it pushes a data nugget into the Postgres database, which causes a notification signal to be sent to QGIS, which causes it to refresh its display, for example, or refresh the layer. So the Postgres connector, basically, when you set it up, you just got to go and configure the connection details, like what the server, the host name, and the username, and so on are. I'm using Postgres running in Docker, and it uses an SSL encryption for the connection, and that is actually broken in Node-RED. So I've got like a patch, which if anybody wants it, I can share, which actually lets it work over an encrypted connection as well. Well, it's specifically over the SSL require mode that my patch fixes it. So I've got this Postgres node here, and then I can like basically go and create a function here and take its output and drag it to Postgres. And I can tell Postgres that like I want to send on the output. You see at the moment it doesn't have a little box here, but I can tell it to send on the outputs that it receives. And now there's a box there, so it means I can connect something else to there. I'll just do the same thing of putting a debugger here. And then of course I need to trigger the actual flow like this. And then in this function, I basically need to just write a query. And if I want to know how to formulate a query, you can go look. Every node has documentation for it. And you can kind of just take the example that they give you. The documentation is a little bit broken, in fact, because it actually wants an array of queries. So I'm just going to wrap it around like this. And I can say message.payload, always be passing it as the payload. And then this query, I can just, you can see here before I delete all this stuff, you can see it supports like parameterized queries. So you can pass it parameters that came from the previous payload, for example, unpacking some JSON and interpolating it into the query by using like a dollar variable name like that. For a simple query, we don't even need to do that. So I'll just select star from OwnTracks.event. You don't need to put the semicolon at the end of the query. And since I don't need these parameters here, I'll just take them out. And then this one is important. Caught me yesterday when I was demoing it. So you need to tell it that we want to capture the output. Otherwise, it basically just runs the query and then silently finishes.
One question. The OwnTracks schema, I mean, how is that set up? Did you?
I'll show you in the main flow. But basically, I built the schema on the fly. So that's not, they don't do anything. I just created a table which I called OwnTracks. I created a schema called OwnTracks, and I created a table called events. And I basically looked at the different data properties that provided on the message that gets sent via MQTT, and I made fields to match those more or less. I added a couple in the left, a couple out as well.
But it's not like something from the OwnTracks documentation that you implemented. It's something that you just custom built from the data you were consuming.
Quickly here and show you here. So yeah, I basically construct a schema. If it doesn't exist, I create the OwnTracks schema, and then I just told it to make this, like make a table with an ID, a geometry, and I did, obviously we're getting a lat and long as, separate broken out attributes, so we're going to combine those later to make a geometry. And then I pulled in all, I just created fields for all the other things that I wanted to pull out of the message. So I'll come back to that in a second. So this one is like kind of, again, the hello world of doing a Postgres query. So I'm just telling it, give me everything that's in my Postgres database. And I can show you here. So if I'm in the database, I can say select star from. You see, I've basically got, whatever, how many 100 rows in the database here. This is basically what I'm trying to do, but using Node instead of just as a command line query. So let's see if it does the same thing here. So I just need to deploy again, and then we look over here, clear that away, and so let's put this a bit, make it easier to see what's going on. All right, and we hit this button, and then it runs our query. And what it did was it gave me back an object, one per table row. So if you go dig into any one of those, you'll find that it's one record from my database table. And that object I can then treat in the flow like I can go and like pass it to a table, for example, or manipulate it in any way I want to. So that's a basic concept. So I'll just quickly do a little walkthrough of the actual flow that I made, and I'll jump over to QGIS and just show you how we can actually then take the data out of the database that we've been pushing from our phone and do stuff with it in QGIS. I just want to mention as well, the MQTT is not specific to OwnTracks, so it's its own protocol, and you can use like Internet of Things devices, many of these like ESP32 and Arduino and Raspberry Pis. They can all like install an MQTT client or sender on them and push messages out on the bus as well. So you could have like a pump station monitoring device or anything like that, like sending messages as well, ideally with the location, obviously, in our context. So to have a look at this flow, I'm just going to zoom out a bit again. So the way that it works is basically it's got a few different activities. The first activity is over here, which is basically to create that table in the database if it doesn't exist already, and the schema. And it just does that every time you start the flow. So it always makes sure that there's the proper schema to push the data into. I've been experimenting with making some PDFs, so this thing's not working yet. And then there's another flow here, and these two things are sort of interpolated into each other. This one is a button, so basically it adds into the user interface this button over here, and when you click it, it does a similar query that I just did in my Hello World version, but instead of just like putting it in the message, in the debug message, it actually loads the data into the table and charts and so on. So the phone doesn't keep history of once it's sent the message and the message being received, it forgets about it. So if you want to go back and store the state of what happened on the system, you need to put it in a database or somewhere. And if you open this dashboard without having connected to the database, it will just have the latest entry that came from the phone. But you could then go and like pull the data back out of the database, which is what I'm doing there by clicking on this button. So that button there is sort of semantically equivalent to also a message coming in from the bus. The only difference is in this case, this button will pull in all 500 or whatever previous messages and one by one push them out into this flow. Whereas this one, typically the messages are coming in one at a time from your device. So in both cases, the goal is to construct a document which looks something like this, which is just a JavaScript object with all those same properties. And the properties are being taken out of the payload. In some cases, I rewrite the name to be more friendly. But ultimately, what I end up with is an object that's sort of got this structure to it. And then that structure can then be passed on to different objects in the workflow. So for example, I can take the payload object and pass it up to here, and this one will strip out just the row, or actually basically it just does some little extra bits to tell the table I want to add a new row, and it passes the payload from the original message into the table and adds a new row to the table, basically. In another case, it might pass it to like the altitude flow here, and this one, like I did in my Hello World, it just pulls out the altitude attribute and then passes that over to two widgets. One is the style widget, and you'll see there's some configuration options, so you can say what the minimum, maximum ranges are, and you can give it a name and so on. And in the other case, it's passing it to the altitude history chart. And again, it's got various options. You can choose which kind of bar chart you want to see, or polar, or what have you. You can set the data minimum, maxima, and you can do other things like run it as render it as a Bezier curve or a linear chart and so on. So in all cases, basically, it just pushes them through these different nodes and ultimately onto a widget of the dashboard. In this flow here, it also, because the data came from the MQTT side, it actually also pushes the data into my Postgres table. So it might be interesting just to look at this one here. and you'll see I have now used like that template system that I showed earlier. So in this case, I'm basically just doing an insert SQL command, passing it the list of attributes from the MQTT payload and inserting them into the table. And then that's the query like definition, and then you pass it over to Postgres and it executes the query. So that's the basic approach. I don't know if anybody had any questions in the chat, but before I switch over to QGIS for the last 20 minutes and just show how we then hook into that from QGIS.
I don't see any questions in the chat yet.
I have a quick question about the Postgres database. I've noticed in the query you specified params as the entire message payload and not
your audio is breaking up a bit, Vicky, but are you asking about this query?
Payload lat. So will it immediately recognize that lat or long was part of the payload?
Yeah. So you're breaking up a bit, but your question, if I understand you right, is you're saying over here, I'm saying lon and let. Like, where does it know to get these from? It gets these from this params object, and yes, it just goes and looks at like param.lon, param.let, and as long as they're defined, actually maybe a bug there, but yeah, it would look for all these properties in the object that's getting passed to it. I need to check back in the payload whether I called it long or lat or latitude or longitude. But I think it is actually correct as it is. Did I answer your question, Vicky? You're breaking up.
Yes, you did.
Okay, great. Okay, so knowing that we've got that in place, and that basically builds this nice dashboard, which is fun. You can look at it in your web browser, but obviously we want to get the data into QGIS so we can do stuff with it. So we can shift over to QGIS over here now, and then no, it's not QGIS. That's QGIS. And so what I've got here is a project where I've basically taken that data now, and I've kind of added it to QGIS. So I'm just going to walk through like how I actually created this layer, and I just use some basic cartography functions in QGIS to do this. And in that same database, I've also got just a bunch of OpenStreetMap layers for the background. That's not really relevant to what we're showing with this. So if I just do make a copy of this layer and duplicate, and then just hide this one and just put this back to simple points again. All right, so that's kind of, oopsie, I'm supposed to get rid of those. That's kind of how the data would come in off the system. And because the data has now been structured in a way that we've got those other attributes, plus I've also done some things to pull out the time. I put two timestamps in there. One is the timestamp of the event as it happened. And the other one is the timestamp of when the insert happened into the database. They may be different because if your phone was disconnected from the internet, there may be some like gap between being able to actually push the data over MQTT to Node-RED and then into your database.
And OwnTracks, does it have offline support?
Yeah, so it will just store up all the messages, and then when it's got connectivity, it will just then push them all out in one big, burst of messages, which is why it's not useful to store the insert time as the as a proxy for when the event happened, because it's not always matched to actually when it was collected, but rather when the data got sent. But you could use the delta between these to see how efficiently is the data getting from your device to the database.
Or when and where people are having connectivity issues and so on.
Yeah. So having date in date and time in the database is obviously great, because if you've been following QGIS, you know that we've got since 4 or 5 versions back, we've got temporal support in QGIS. So you can just go down to here and you can say there is a single field in here which has the the time of this point. So I've set it to event time here, and I can say how long each point should last in minutes, or in whatever time units I want to use. And that then puts this little icon next to the layer saying this is like a temporally enabled layer. And that means that I can then open the temporal controller over here. Just get a bit of extra space in my QGIS here.
You don't have to use the context menu. There's a button for it up next to the refresh canvas button. I think
good, thank you. Okay, and so I can enable that, and then I can tell it to, basically it's going to scan through every layer which is temporally enabled. If I click on this button over here, I will find out the minimum maximum range of the start and end time across all of those data points. And then you can go and tell it what the time increment should be. If I play this, it's jumping at 30-second intervals. So I live over here somewhere, and my office is over here somewhere. So it's kind of a bit slow. But if you wanted to speed things up, you could go and or you could either just scrub it through like this. Okay, so you can see some things happening here. That's me at my office.
I think you set your event duration a bit short, maybe.
Well, yeah, it's just going to flash on and off if I do that. But there you can see me going for a walk. the walk
there we go.
That I took earlier where the dog bit my leg like an hour ago. So, yeah. So if I wanted to, I could go and make a note of when did that happen. I could just stop over here, scrub a little bit back, and then take that time. So that's 1440, for example. 1440 of the 24th. Make that the left limit, and then when I play it now, I'm not going to have to look through all of the other stuff that was going on. So that's already nice. We can have some nice little animation effect. You can see that the end time is now also too long because I've been sitting here chatting and my phone hasn't gone anywhere, so it's not making for any interesting events. So I could stop there, which is at 15:12. All right, and then I get just kind of that little bit of activity that I was on when I was on my walk. And then you can start to play with the information that's embedded inside of the event table to do the cartography in a way that kind of shows you some of the things that were happening. So I'm going to switch this marker type to use this thing called the field vector marker. I think it was only added maybe a version or two back. Maybe Charles, you can remember. I don't know when it was added. But this takes different attributes from your attribute table and then will draw it differently depending on how those look. So I'm going to, first of all, just change this to be an arrow, rather. And it still doesn't show anything because I need to go back just to this over here and set the attribute. So I'm going to make the X attribute the velocity. All right, now you can see my arrows flying around like that. And I'm going to make the Y attribute the course. Okay, and then I'm just going to scale it down a bit to like 0.1, something like that. And then I need to change this to be a polar field type. And then you can see the arrow is now actually pointing in the direction where I was heading. And then we could go just tweak this arrow a little bit here, and we could say, like, let's make the, first of all, I can just change the basic colors and things like that. Get nice and red or something like that. And then we can go and, sorry, that's the wrong one. Go here, and we can change the width of it to wider, something like that. And then we can set the, where's the width? No, it's this one here. Got to go thin and then thick. Yeah, and so you can basically create this like animated thing with an arrow showing you from the phone the information of where you were, which direction you were walking and how fast you were walking. And then if we wanted to, we could actually change this color here to be maybe something based on that velocity as well. So I'm just going to use this assistant here and take the velocity here. I'll set like the value from 0 to, I don't walk too fast, so I'll go like to 8 kilometers an hour, for example. And you'll see that like I'm generally walking the same speed in these parts, but we could try to make the difference between speeds more exaggerated. So let's say when I'm going slow, we want more of that, and then when I'm going fast, we want it to really ramp up the color like this.
Maybe use a diverging color ramp or something that makes it more extremely visible. There you go.
Cool. And then you can just play with it as you have all this nice spatial temporal data at your fingertips. You can use all the tools that QGIS provides and do any visualizations you want to. I'll show you again the one I prepared here, which what I did was I also put a little label next to it to show the speed that I was walking at. And if we go back to like this morning, you see where I was speeding in my car, trying to get to work. I think I actually might have deleted my tracks from this morning, although I think I saw them earlier. So let's just have a look.
You got rid of the evidence.
Okay, that's my walk from just now.
So I have a question regarding like analysis. Like, where in this stack would you say is the best place for analysis to happen? Say, for example, I had 2 field agents, and I wanted to get some sort of notification when they came within 3 kilometers of each other, or whatever.
Right. So that's where I'd probably
you,
use the PG notify to do like a geofenced thing. But there is actually also support on OwnTracks itself to create these geofences and then send a message when somebody moves out of the geofenced area. So you could do it on both sides. You could have OwnTracks set up so that it's got these like areas where you want to kind of make sure that the person stays in, what have you. But then you could also do it on the Postgres side where you actually say like, I want to create some polygons and then send an event using PG notify to any listener if there is something happening. Or you could even do it without using PG notify, just by polling the database in Node-RED regularly, for example, or polling the database in QGIS regularly, because you can in here in the rendering options here, you can tell it to refresh at certain intervals. That just cartographically updates the things. So Node-RED is kind of useful in terms of actually triggering some activity to happen. Like triggering an analysis workflow in QGIS using the processing model or something. Node-RED would probably be a nice way to do it because you get the event in Node-RED and you just say like shell out. And call this QGIS model and then.
So are there nodes in Node-RED? Are there nodes for? So at this point, it's largely an event-driven kind of framework from my understanding of it. Just IoT capturing telemetry regularly, being able to capture messages as they come in. But it does have these kind of like you've got there like your timestamp, and you can it must have, I'm sure, nodes for setting up like polling and doing some sort of like interval based checks. But it doesn't at this point. There are no like nodes inside there that have some sort of spatial intelligence or location analysis. You'd have to build those out using either queries to PostGIS or QGIS. Like you said, you can use a QGIS model. Or anything like that, but there's nothing like out of the box that's going to give you spatial support.
Not that I've found, but I didn't mention, but there's this thing called the palette, which is like our plugin repository in QGIS, and there's like 3,500 things in here, so there might be like geofence, or I don't know. Yeah, there you go. People have built lots of cool plugins here, so try them out. You could kind of try one and see how it works, and you just install it like that, and it just adds a new node into your palette. You can see what it looks like.
So I imagine there's about to be a lot more nodes available with geo in the name.
Yeah. And here, let's see. Oh, you can go just draw a fence. Okay, so I could just go to where I live, and then I guess draw a polygon around here. Very nicely done. Yeah.
I do find that Node-RED is like a really interesting tool. Like I kind of view it like the kind of equivalent of the graphical modeler, but like outside of a single ecosystem. It's just a big like ETL transformation framework where you can just digest data from so many different like endpoints and data sources, and then manage it all together. And then it gives like a nice client front end as well, which is awesome.
And what I haven't shown is you can also build forms and other interactive things. So like you can have somebody type in something into a form and then push it into the database, or push it out in the MQTT feed or what have you. I should mention one of the reasons I knew about it for a while, but one of the reasons I started taking a deeper look at it is because I think that we have a QEP. Did we have the? I don't know if anybody in the chat knows if there's the new QEP yet, but for QGIS modeler improvements. I may be jumping the gun, but Ujjwal has been sort of leading some thinking about how we could improve QGIS modeler, and I started looking again at other modeling, like flow-based modeling tools, to see how they work, and to see where we can take inspiration from that. I don't know if he's actually made it yet. anyway, I think you can. I won't steal his thunder. I'll let him announce it when he's ready. But I think there's going to be some crowdfunding and things around that as well. But yeah, no, it's really friendly and powerful. Lots of great functionality, and like if you're working in a geospatial stack with QGIS and what have you, you can do some really nice things with it. And I don't have time to show now, but I've even done things with like QGIS server. You can pull in. There's a mapping module in Node as well that you can have like a web map, and you can pull WMS layers in from QGIS server. And I've also done things like where you can trigger QGIS prints based on data that's being pushed into the database and use QGIS to build PDF reports and things. So there's lots of scope for like combining QGIS and Node-RED into interesting workflows. And that's my story. I'm going to just see if anybody's had anything interesting to say in the chat here, other than hello from Ismail and Ethan and Gregor and everyone else who joined. Thanks for joining in the chat room. And I hope you, if you make something interesting in Node-RED and you just share what you do, I'd love to see what everyone gets up to. And I think we can end there. Thanks, everybody. We'll see you next open day. We're looking for more speakers. So if you want to give a talk, please contact me or Amy. Actually, Amy, it's better to contact Amy or CLBware or Vicky and let them know about your planned talk, because it would be great to have some fresh ideas and faces. And thank you to the speakers that presented earlier today. It was very interesting to see your work. All right, so we'll stop the stream here. Thanks, everybody.
Cool. Thanks very much, Tim. That was very interesting.
Thanks, Tim.
Okay, we're not streaming anymore, I think. No,